Okay, so it says a plane is traveling at a bearing of north 17 degrees west at a speed of 395 miles an hour, and the winds are blowing at a speed of 75 miles an hour in the direction of north 19 degrees east. So I'll go ahead and draw this picture. So let's say that this is like where I'm starting. So the plane is going to be heading off at a bearing of north 17 degrees to the west. So this is west. So this is that angle right there. And the vector, the magnitude is 395. So that's our first part. I'm going to call that P vector. That's going to be the plane. Then the wind is telling us that it's blowing at north 19 degrees to the east. So this angle up in here is the 19 degrees. So this vector is the wind vector, and that's blowing at 75 miles an hour. So then the true speed of the plane is the sum of these two vectors together. So that's our true bearing. And our true bearing is this little one over here. So we'll get to that in a second. But when it says draw a picture of the diagram, this is what it wants for part A. You want to label all the pieces together, and then the two parts that we're going to find is this guy here, this magnitude, and then this true bearing, okay? So then part B says, what is the true speed of the plane? So here's how you think about part B. It's probably the hardest part for a lot of folks. So remember, right, if I'm starting here and this angle was 17, if I draw a transversal that goes through two parallel lines, then these two angles are going to be the same. So this is 17 degrees and this is 17 degrees. We already knew this was 19 degrees. So the whole entire angle we know is 180. So I took 180 and I subtracted off the 19, and I subtracted off the 17. That left me with 144 on this inside angle. So really what you've got here is you've got a side angle side triangle. You know this is now 75. The angle in the middle is 144. And this is 395. So you've got side angle side implies you're going to use the law of cosines. So we're interested in this, which is the true vector, which I called T vector. Okay, so how do you get that? Well, we're going to do law of cosines for part B. And here's all my work. So I'm going to call that T squared is 75 squared plus the 395 squared minus 2 times 75, 395 cosine 144. Make sure you get that in your calculator. Then you take the square root of all that, and that gets you to 457.8. That's the true speed. That is the speed of the airplane plus the speed of the wind. Then part C is asking us for the true bearing. So here's what we're going to do. Remember, when we started this, right, we knew that this whole angle was 17 degrees, but there's a little bit of it that has been cut off by the triangle, and that's our true bearing right there. So I'm going to figure out what this angle is, this little angle here. I know it's going to be smaller than 17, and once I do, I'm going to take 17 and subtract it from whatever angle that is, and that's going to be my true answer. So I'll call this theta. I'm going to go ahead and use the law of sines. Remember, in this triangle here, right, this was 144, and this was 457.8. So I'm going to use law of sines and say the sine of this angle over 75 is the sine of that angle over that. Do the math, take the inverse sine, that gives me 5.53. Now that's not the answer. That's how much I subtract from 17. So 17 minus this blue angle here gives me the leftover part, which is 11.47. So the true bearing of the plane is north 11.47 degrees west.